ISTB presents, in association with Dhanmanjuri Community College, DM University Imphal, launching a series of educational programs, recorded online classes for undergraduate and postgraduate students by teachers from various colleges and universities. During this COVID-19 lockdown, every day on ISTB Nongin, 8 p.m. from 24th May 2020 onwards. What's for that? Only on ISTB Nongin.
Good morning, dear students. Today, let us discuss network analysis PERT CPM. This network analysis is very important chapter in the operation research. PERT means program evaluation and a review technique, and CPM, critical path method, are the network techniques used to aid in the planning, scheduling, monitoring, and control of activities which are related to each other. For example, CPM is frequently used in the construction industry to help organize and schedule those activities which together constitute a given construction project. In using critical path method, we assume that the activity times are known with certainty. Deterministic activity. In the case of PERT, the activity times are uncertainty, stochastic activity. So this is the difference between CPM and PERT. PERT works on stochastic activity, CPM works on deterministic activity. A project such as construction of a bridge, highway, power plant, repair and maintenance of an oil refinery, or an airplane design, development and marketing a new product, research and development, etc., may be defined as a collection of interrelated activities or tasks which must be completed in a specified time according to a specified sequence and require resources such as personnel, money, material, facilities. The growing complexities of today's project had demanded more systematic and more effective planning technique with the objective of optimizing the efficiency of executing the project. Project management has evolved as a new field with the development of two analytic techniques for planning, scheduling, and controlling projects. These are the CPM and the PERT. PERT and CPM are basically time-oriented methods to the determination of a time schedule. Project scheduling by PERT CPM, it consists of three phases: planning, scheduling, and controlling. Under the project planning, we have to identify various activities to be performed in the project. Number two, determining requirement of resources such as man, material, machine, etc. for carrying out activities. Next, estimating costs and times for various activities. Next, specifying the interrelationship among various activities. Lastly, we have to develop a network diagram showing the interrelationship between the various activities. Scheduling. Once the planning phase is over, scheduling of the project is when each of the activities required to be performed is taken up. Based on this time estimates, calculation of total project duration by applying network analysis techniques such as forward and backward pass and identifying the critical path. Project control. Project control refers to re-evaluating actual progress against the plan. Activities. Activities of the network represent project operations or tasks to be conducted. An arrow is commonly used to represent an activity, with its head indicating the direction of progress in the project. Events in the network diagram are identified by numbers. Activities are identified by the numbers I, j, where I represent the start of the activity, j represents the completion of the activity. So in a network diagram, only one and only one arrow indicate the activity. Determination of the critical path. An activity is said to be critical if a delay in the start of the course makes a delay in the completion time of the entire project. A non-critical activity is such that the time between its earliest start and its latest completion time is longer than its actual duration. A critical path defines a chain of critical activities that connects the start and end events of the arrow diagram. So now there is one problem. Let us see this network. Consider a network which starts from node 1 and terminates at node 6. The time required to perform its activity is given below. Find the critical paths. So let us see how the critical path is determined. So first we have to draw the network diagram. So here activities are given, time also given. Activity first 1 to 2 events are denoted by numbers. So activity is indicated by arrow mark from 1 to 2. Time duration of this activity is 3. Next 2 to 3. Time duration is 3. Next 2 4. Time duration is 2. Then 3 4. Time duration is 0. This is the dummy line. You have to draw the dotted line. This dotted line represents the dummy activity. So time duration is 0. Next 3 5. 3 5. Activity 3 5. Time duration is 3. Next 3 6. Time duration is 2. Next 4 5. Activity 4 5. Time duration is 7. Next 4 6. Time duration is 5. The last activity 5 6. Time duration is 6. So this is the network given by this data. So now we have to find the critical path. So first you draw here one rectangle. You put here. Then you put here. Yes. Then last you put here. So let us start with forward pass. Let us start with forward pass. So you write ES1. This is E means earliest start at activity 1, event 1. So we have to start from 0. At initial event, the initial time will take 0. Next, ES2, this is the earliest start at S2. S2 means event 2. So time duration is ES1 plus D12. ES1 means 0. D12 duration is 3. So it becomes 3. You write 3 here, 3. Next, ES3. ES3 means ES2 plus D23. ES2 3 D2 3, time duration is 3, so this is 6. We have to write 6 here. Next, ES4. ES4. So this 4, there is a 2 roots, one from event 2, one from event 3. So we have to write this maximum. ES2 plus D24, comma, ES3 plus D34. So this is maximum. ES2 3, D24 2, ES3 6, D34 0. So this is 5, this is 6. We have to take 6, then we have to write 6 here. Next, ES5. So here, this 5, there are 2 roots, one from node 3, one from node 4. So there are 2 roots. So we have to write maximum value ES4 plus D45, ES3 D35. This is equal to maximum ES4 6, D45 7, ES3 6, D35 3. So this is 13, this is 9. We have to take maximum value 13. We have to write here 13. Then finally ES6. So in node 6, there are 3 roots from node 4, from node 5, from node 3. So you write maximum ES4 plus D46, ES5 plus D56, ES3 plus D36. This is equal to max ES4 6, D46 5, ES5 13, D56 D566, ES3 6, D36 2. Time duration is 2. Duration of the activity. So this is 11, this is 19, this is 8. We have to take 19. So you write 19 here. So this is the forward pass. Next we start with backward pass. Backward pass. For the backward pass, say we use another symbol like this. You put triangle shape here. We have to put triangle shape here, triangle shape here. So here you put triangle shape. For the backward pass, first we have to write LC6. L means latest completion time at node 6. This is 19. You write 19 here. We have to write 19. Next, LC5. Latest completion time at node 6, node 5. So we have to come from node 6. LC6 minus D56, LC 619, D56, 6. It becomes 13. We have to write 13 here, 13 here. Next, LC4, LC4. LC4, there are two roots, one from node 6, another from node 5. In the backward pass, we have to take the minimum value. Minimum LC6 minus D46, LC5 minus D45. This is equal to minimum LC6 19, D46, D46, duration is 5, LC5 13, D45 7. So this is 14, this is 6, we have to take the minimum 6. So here we have to write 6. Next, LC3. LC3. So there are 3 roots, one from node 6, another from node 5, another from node 4. So we have to write minimum LC6 minus D36, comma, next from 5, LC5 minus D35, LC4 minus D34. This is equal to minimum LC6 19, D36 2, LC5 13, D35 here 3, LC4 4, D34, this is dummy 0. So the minimum is 17, 10, 4. So we have to take 4. LC3, no, this is LC4. LC4 means 6. This is 6, 6 minus 0. So we have to write 6. Have to find LC2. LC2. There are 2 roots. So minimum LC4 minus D24, LC3 minus D23, LC4 minus D24, LC3 minus D23. So there are 2 roots from node 4 and node 3. So minimum LC4, LC46, D24 2, LC3 6, this is 6, D23, this is 3. So this is 4, this is 3, you take minimum. So you write 3 here. Finally LC1. LC1 means LC2 minus D12, LC2 3, D12, duration of the D12 is 3. So this is 3, it becomes 0. We have to write 0. So this is the backward pass and the previous one is the forward pass. Now we have to check the critical part. So here we have to check the difference 0 and 3, 3, 0, 3, 3. Difference is equal to this 3. So we have to another line. Then next 2 to 4, we have to check 6, 3, difference is 3, but here is not 3, there is 2. So we will not go on this side. Here 3, 6, 3, 3, 6, 3, difference is 3, so duration is 3, so this is okay. We have to you draw another line and making bold. Then next, let us see. This is 6, this is 6, 0. This is 6, this is 0. So this is the 0. So this we have to draw another dotted line. So next, this is 6, this is 19. Difference is 13, not equal to 5. Here we have to check. This is 6, this is 13. Difference is 7. This is 6, this is 13, 7. This line is okay. You draw another line and making thickness. So here 6 and 19 difference is 13, but this is 2. This is not true. And here 6, this is 13, 7. So this is not equal to 3. Finally, we have to check this. This is 13, this is 19. Difference is 6. This is 13, this is 19, difference 6. This is okay. You draw second line. Yes. So finally, the critical part is node 1, 2, node 2, next 2 to 3, next 3 to 4, next 4 to 5, then 5 to 6. This is the critical part. Critical activities are 1, 2, 2, 3, 3, 4, 4, 5, 5, 6. These are the critical activities. Hence, the duration of the project, duration 1 to 2, time duration is 3, 2 to 3, 3, 3 to 4, 0, 4 to 5, 7, 5 to 6, 6. This is 6, 19. The duration of the project is 19. This 19 may be number of days or number of months. This is according to the problem. So this is the method for finding critical part. So this is the CPM. So by using this CPM method, we can calculate the duration of the project. In this network, the time duration of its activities are deterministic, means constant, already known. If the time duration of its activities are not known definitely, then we have to apply PERT technique. Duration of this activity are not certain, stochastic, then it will be applied by PERT. So in the next class, I will take up the technique of PERT in the network analysis. Today, let us stop here. And one assignment problem also here. I will give you, there is one assignment. So a project consists of a series of tasks A, B, ... with the following respective time of duration. Find the minimum time of completion of the project and the critical path. So you practice this problem by using this technique. Thank you.
ISTB presents, in association with Dhanmanjuri Community College, DM University Imphal, launching a series of educational programs, recorded online classes for undergraduate and postgraduate students by teachers from various colleges and universities. During this COVID-19 lockdown, every day on ISTB Nongin, 8 p.m. from 24th May 2020 onwards. What's for that? Only on ISTB Nongin.